Today, I'll show you why any planted tank, dare I say, needs CO2. Stay tuned for Science Alliance. Hey folks, Nick Mock 007 here for the very first episode of Science Alliance. Now, as we hinted in the teaser video, I will present one side of an issue, but to see the other side and actually get a balanced view, you gotta go check out my bud Cam's channel. There's the link, but I'll also put it in the description. Once you watch these two videos, you make up your mind. So remember, my job today is to convince you to use CO2, or carbon dioxide, in your tank, not to present a full view of the topic, so let's keep that in mind. If you have any ideas that you'd like to see us cover in future episodes, email us. I'll put a link for our email in the description below. Also, we set up a poll. We thought it would be neat to see what we're all doing. So it's a real short, simple poll, but it'll give us a glimpse into who's actually using CO2. Then we can all see the results. All right, on to the debate. So if this is your first day on planet Earth, let me first welcome you. You must have heard that all life on Earth is structured around carbon, what people usually say is carbon-based life forms. It's the same reason why all doctors have to take orgo or organic chemistry. It's just a fancy way of saying the study of matter that contains carbon atoms. Now, plants, they're made up of 40 to 50% carbon. Now that's the dry weight of plants. Submerged aquarium of plants absorb carbon through a variety of means, but primarily through carbon dioxide, which of course, CO2, is dissolved in the water. All aquarium plants will benefit greatly from adding CO2 to the water. Now, let me say that again. All aquarium plants will benefit from adding CO2. But if you want to keep a heavily planted tank full of lush green growth with little or no algae, then I consider CO2 to be essential. But before we focus on CO2, let me also tell you that plants can meet their carbon needs by splitting carbon directly from carbonates in the water. Now, while that method is useful in the wild, it's not so desirable in our aquariums, because when plants draw on calcium carbonate in the water to meet their carbon needs, a process called biogenic decalcification, the water has less and less buffering capacity. Now, what that means is, without that buffering capacity, you can have big pH fluctuations. Eventually, the plants can even totally exhaust this carbon source. That's why adding CO2 is a much, much better option. All right, so I've told you plants are carbon-based life forms, and the best method to give them carbon is by adding CO2 to your tank. But the question is, what does a plant actually do with carbon? Well, carbon dioxide is used by plants in photosynthesis, or the conversion of water, carbon dioxide, and light into food or energy, simple carbohydrates, with oxygen as the byproduct. Okay, put simply, plants need CO2 to grow. Now, here's a simplified equation showing photosynthesis. Again, very simplified. Through this process, as you can see, plants capture energy from light, CO2, and water to produce glucose, and then they release oxygen. Okay, so in order for this essential process to occur within the cells of plants, there must be CO2 present. You can then think of it as the CO2 promotes growth, reproduction, and the prevention of disease in our plants. So now, there's plenty of CO2 in the atmosphere, on average 350 to 500 parts per million of carbon dioxide. Though this can vary based on a variety of things, altitude, whether you live in a city or not. So isn't that good enough? That's a lot of carbon dioxide. Well, no. In your tank, levels of CO2 are much, much closer to 6 parts per million, whereas the target of CO2 is actually 25 to 35 parts per million. Now, for both terrestrial and aquatic plants, increasing the concentrations of CO2 to 4 to 5 times those levels has been shown to promote faster growth, higher yield, stronger, healthier plants. Don't ask me too much about where I learned that. Hint, I got it on chat boards with growers living in Colorado and California. Anyways, though, on the flip side, low levels of CO2 have been shown to halt vigorous growth, even when all other conditions are ideal. Okay, so it's abundantly clear that adding CO2 promotes unrivaled plant growth. This is, of course, is why we're so limited in what types of plants we can grow in low light conditions. Now, some plants developed in nature to grow under low light conditions, And of course, everyone knows that under low light conditions, these certain plants, things like crypts, can do okay without added CO2. So it's true that there's normally enough CO2 for these less demanding plants to grow successfully without CO2 addition. But if you're interested in growing a wide range of plants with different colors, textures, sizes, then you'll have to consider higher light. And as soon as you increase light levels, then the plants may grow well for a period until they consume the little CO2 that is available. But then they'll be limited by a lack of CO2. Not only will your plants stop growing, but then this will lead to other problems that running CO2 in your tanks can help you avoid. This includes algae. Let me say that again, algae. Now, this is because light and excess nutrients your plants cannot use. So algae's biggest friend is lots of light, little or slow growing plants. Now, adding CO2 allows the plants to use the light and the nutrients available. In fact, sometimes aquarists often increase CO2 to around 40 parts per million because these higher levels can actually block the enzyme production in algae cells. But try not to think of plant growth in terms of a competition between higher plants and algae. An increase in CO2 availability means an increase in carbon, which means there's more growth and more health. Algae attacks when plants are unhealthy and recedes when plants are healthy. So increased CO2 generates healthier plants, which then eliminates the conditions in which algae tends to attack. Another benefit for many aquarists is that using CO2 reduces pH levels. This can often be beneficial to many species of tropical fish. In fact, the majority of freshwater fish that we keep originate from waters with soft and acidic water. Everything from tetras to discus and catfish. Now, a lot of people tell you that pH will swing when using CO2 with a solenoid. That means your CO2 is on during the day and off at night. But here's something that people don't tell you. pH will swing if you don't add CO2 to your tank. I'm going to put up a log right now. This was of a 180-liter aquarium where the pH goes from 7.35 to almost 8 during the daytime. During the photo period, the plants pick up CO2 from water, which makes the pH rise. But then the other half is that the water is more oxygenated, and oxygen is a base, so that also causes pH to rise. All right, so I'm not going to spend too much time looking at that, but I thought that was kind of interesting. It is important to remember that whether you use supplemental CO2 or not, the amount of light, CO2, and available nutrients must be in equilibrium. In fact, I would actually tell you that it's easier to balance these things if you are supplementing with CO2. Let me explain. So, in low-tech setups and high-tech setups alike, lighting and nutrients can be controlled equally well. You can raise or lower the light, you can add more fertilizers, but only when you're adding CO2 can you actually control CO2 by increasing or decreasing this rate. Thus, balancing your tank is actually easier since you can control each one of these variables individually. Now, people will often tell you that CO2 can be dangerous to your fish. So let me say that is true, but, and this is a big one here, so can everything else you add to your tank. It is important to think of supplemental CO2 as an additive, just like fertilizers, dechlorinators, buffers, medications, or even fish food. All of these things can create lethal conditions in your tank when they're added in excess. CO2 is no different. It has to be used within specific parameters to ensure the safety of your tank's inhabitants, but it's just like those other things. So now you should be asking yourself, not whether, but how should I be adding CO2 to my tank? Now, I'm only going to cover these very, very briefly here to point out a few specific things relevant to today's conversation. So you have two main methods. You have your pressurized and non-pressurized, which is often referred to as DIY CO2. All right, let's start with the pressurized. This is by far the most reliable and controllable method of CO2 enrichment. This includes bigger tanks at 2.5s, 5s, 10s, 20 pounds and up. Okay, but this can also include paintball canisters. These are much smaller and cheaper, so remember that point. The advantages are clear. You get very, very fine control of CO2 using these regulators, and it's really easy to automate. Once you have it set up, it's almost set and forget. And with a big enough tank, you only have to refill it once or twice a year. Pretty easy. Now, the second method harnesses fermentation and is usually called DIY CO2. Any home brewer will tell you that CO2 is a byproduct of fermentation. It is the gas found in bubbly alcoholic beverages. A pound of sugar will ferment into approximately a pound of ethyl alcohol and half a pound of CO2. All you need are a couple of plastic containers like an old, 2-liter soft drink bottle and some airline tubing, some yeast, some sugar from the grocery store, and that's it. Now, the advantages of this system will speak to some of the criticisms of pressurized CO2. First off, it's easy to make. It's done with simple materials, you don't really need any real skill. And it's very, very cheap. And it's quite easy to maintain. No real expertise is needed. It's just less intimidating than the pressurized setups. And there are no dangers associated with pressurized gas tanks in your home. Okay, so hopefully I've already convinced you to go set up a CO2 system for your tank. But remember, go check out the other half of this video on Cam's channel. Remember, I gave you a very one-sided presentation, though I agree with everything I said. And if you're actually considering setting up CO2, you got to know both sides of this issue. Remember, send us an email if you have topics you want us to cover, and just take a real quick second to vote in that poll. All of that stuff is in the description. And as always, hit that like button if you enjoyed the video, but feel free to hit the dislike button if you feel I did a terrible job and I didn't convince you of anything. Now, I really do read and answer comments, so let us know what you think. And if you want to stay up to date with my channel, including the Science Alliance series, make sure you're subscribed to me, but also subscribe to Cam. All right, remember, CO2 is what makes beer beer. See you in the next video.